So what we will be doing today is simplifying trigonometric identities. Okay. So the title is simplifying trigonometric identities or expressions. So this is what we are going to do. Now, we cannot explain to you properly this simplification of trigonometric expression or identities if we do not give an example. Okay, so we have to have an example so that we can elaborate properly. So such as we have in here the problem, secant theta over cosine theta minus tangent theta over cotangent theta. Okay, so now our objective in here is we are going to simplify this one. Okay, we're going to simplify this expression, secant theta over cosine theta minus tangent theta over cotangent theta, or the difference of the quotient secant theta over cosine theta and tangent theta over cotangent theta. Now, what are we going to do in order for us to simplify this one? The first thing that we are going to look into is we have to always put this one into its proper form in terms of cosine and sine. Okay, in terms of cosine and sine. But of course, if we are going to reduce this one or simplify this one, now we have to involve the operation. We have the subtraction of rational numbers, okay, or rational expression, so that if we are given this kind of problem, we might be subtracting them first before we are going to convert every identities that we can see in here, the secant, the tangent, the cotangent. Okay, so how are we going to get the difference of this one? Definitely, the very first thing that we are going to do is we have to get the LCD. What is the LCD? So our LCD in here is, if you are going to look into, our LCD is cosine theta, and then cotangent theta. Okay, so after that, cosine theta, cotangent theta divided by cosine, and that is cotangent multiplied by secant theta. So it will give you secant theta cotangent theta. That is subtraction, and so minus. So again, cosine theta cotangent theta divided by cotangent theta. So the answer is cosine theta multiplied by tangent theta. So it will give you cosine theta and tangent theta. And so that is the result. Now after this one, we are going now to convert every expression into its definition in terms of sine and cosine. So the next thing that we are going to do is, what is the definition of secant in terms of cosine and sine? So if you will notice, I will get the definition of this one. Secant theta is the same as 1 over cosine theta. So that is multiplication. Okay, so we have in here. Now, what about the cotangent? Cotangent theta is the quotient of cosine theta over sine theta. Okay, so that is the cotangent minus cosine. Okay, cosine theta. Now, what about this tangent? That is the same as we assume that this has a denominator of 1. So, ayan, denominator of 1. Okay, so you will notice that is tangent is the same as sine. Okay, sine theta over cosine theta. Okay, so that is the result. So, this is of course over the denominator cosine theta cotangent theta. Now notice that when we are going to consider the expression, now there are some that will cancel out. So notice that the cosine in here will cancel out. Okay, another one, this will cancel out. So what is left now? What is left now is 1 over sine theta. So we have now the next thing that you can see is we have 1 over sine theta. Okay, how about here? That is the same as minus sine theta over 1. Okay, of course we have a denominator in here. So notice that we have a denominator that is cosine theta. Now, cotangent has also its definition. Now, what is the definition? What is the definition of cotangent? That is the same as cosine. So we have in here cosine theta over sine theta. Okay, over sine theta. Okay, so that is the resulting expression. Now, after that one, notice that this is the difference of fraction and whole number. And what about this one? This is the same as multiplication of fractions. Okay, multiplication of fractions. Now, the next thing that we're going to see is we're going to get the difference of this one. So let's try to use it here. So that is the same as what is the LCD of the two. So the LCD is that is the same as, okay, let's try to have, okay, so notice that we multiply first this one. So we have in here cosine squared theta over sine theta. Now, what about the numerator? What is our LCD? Our LCD is sine theta. Okay. Now, sine theta divided by sine theta, that is 1 multiplied by 1. So that is the same as 1. Okay, so that is the same as sine theta divided by the denominator of this one, which is 1. That is the same as sine multiplied by sine theta. It will give you now minus sine squared theta. Okay, so that is the result. Okay, notice that in the Pythagorean theorem, this can in the Pythagorean identities, this can be considered, okay, a result of cosine. But what we will be doing in here is we do first the expression. This is division of two fractions. So how are we going to divide? When we are going to divide, get the reciprocal of this denominator and then proceed to multiplication. So when we are going to do that one, that is the same as 1 minus sine squared theta over, okay, over this one, sine theta, okay, and that must be multiplied by the reciprocal of this one. What is the reciprocal? That is sine, okay, sine theta over cosine squared theta, okay, ayan, squared theta. Notice that the expression sine will cancel out, okay. What is left now is this one, 1 minus sine squared theta over cosine, and over cosine squared theta, okay. Now you notice that when we are going to look into this one, the result is we have in here 1 minus sine squared theta over cosine theta. Remember that cosine squared theta in the Pythagorean theorem, the value of this one is actually the value of this one in the Pythagorean theorem. Now let's try to consider the Pythagorean theorem in here. That is sine squared theta plus cosine squared theta will give you 1. So that if we are going to get the value of this one, the value of this cosine in here from this Pythagorean identities, cosine squared theta is actually 1 minus transpose that one, it will give you sine squared theta, okay. So that by substitution, we will use this one to substitute our denominator. So when we substitute our denominator, it will give you now that is the same as numerator na 1 minus sine squared theta over, by substitution, that is the same as 1 over sine squared theta, and so you will notice that they are the same. So if we divide that one, it will give you a result of 1. So the final answer is the same as 1. So the result of secant theta over cosine theta minus tangent theta over cotangent theta is actually equal to 1. The next thing that we are going to show simplification is we have in here secant theta, the product of secant theta, cotangent theta, and sine theta. So again, we're going to simplify this one. What would be the resulting function or resulting expression if we're going to put this one? Now I use this paper so that it will not stain the curtains of my or the table runner or my table runner. So now when we are going again to simplify this expression, we should always remember that when we are going to simplify, we have to convert them into, or in terms of, we have to convert them in terms of sine and cosine. So that is the technique of how to convert. So how is that? So what is the definition of secant theta? So if you notice, the definition of secant theta is the same as 1. Okay? 1 over cosine theta. Okay? Of course, that is multiplication, so we have to enclose with parentheses. What about the cotangent theta? The definition of the cotangent theta in terms of sine and cosine is cosine theta over sine theta. Okay, ayan. Now, what about this one? You assume that this is the same as sine theta over 1. Okay? So, notice, multiplication of fractions. Now, if you try to evaluate or if you try to notice the expression converted the form of the expression, the cosine will cancel out. The sine will cancel out. And so what is left now? What is left now is we have 1 multiplied by, ayan, 1. Okay? 1. Okay? 1 over, what is left is 1. And so what is the result? 1. Okay? So the result of the expression is actually 1. So the product of secant theta, cotangent theta, sine theta is 1. Okay? So it's very easy. Okay. Our next focus is simplifying trigonometric expressions into a single term. Okay? So to illustrate this, we need to have again another example. So our example in here is the product of secant theta and cotangent theta. Now again, what is the technique of simplifying trigonometric expression? Again, memorize the basic identities such as the reciprocal identities, the quotient identities, and the Pythagorean theorem identities, because these are the thing that we are going to use in order for us to simplify complicated expression like this. Okay, but anyway, our expression is very simple. So again, what is the number 1? What is the definition of secant theta? So secant theta, if you notice, that is the same as 1 over cosine theta. Okay? Multiplied by cotangent theta. What is the definition of this one? Okay, that is under the quotient identities. That is the same as cosine theta over sine theta. Okay? Notice that when we are going to look into the expression, we can cancel out. That is the same as cosine. And so what is left now is we have 1 over sine theta. Now, our instruction is we have to convert this one into a single term. This is a single term, but it is in fraction. But notice, 1 over sine theta is actually the same as cosecant theta. Okay? So, ayan. So, it is the same as cosecant theta. So, the result of our example, which is the product of secant theta and cotangent theta, is actually cosecant theta. So, that is the result. Okay? That is the result. Yan. So, meaning, the product of this one is cosecant theta. Okay? The next thing that we're going to have is cotangent theta. Cotangent squared theta minus cosecant squared theta. Notice that the expression or the trigonometric expression, when we are going to put it into a single term, now notice that this follow a rule in algebra, which is the same as the difference of perfect square. If we are going to have that one, that is the same as x raised to 2 minus y raised to 2. And so if you have that one, if you have this one as the same as in our expression, Now we can expand. So the first thing that we are going to do is we have to expand this one. So when we expand, this is the same as the difference of two perfect square. We follow this one. This is the same as x plus y multiplied by x minus y. Okay? So, meaning, these are ideas or concept under the algebra which it can be applied in our trigonometric expression. Okay? So, how is that? How is that? Our cotangent squared theta is the same as our x, and cosecant squared theta is the same as our y. And so if we are going to follow this one, we just say that if this is your x, this is your y. Now we just say that cotangent theta plus cosecant theta. So that is one of its binomial factor. Okay, the other one is cotangent. The other one is cotangent theta minus cosecant theta. So that is the other binomial factor. Now notice this one. When we continue, we try now to get the definition of this cosecant and cotangent theta in terms of cosine and sine. So what is the definition of cotangent? Okay, so that is the same as cotangent is cosine theta over sine theta. Okay, so this one, cotangent theta is the same as cosine theta over sine theta. Plus, what about this one? So what about this one? That is actually the definition in terms of cosine and sine is 1 over sine theta. Okay, so that is how to simplify. Now what about this one? The same. Okay, same. Cotangent theta is the same as cosine theta over sine theta. Okay, minus. What about this one? The same. 1 over sine. Okay, sine theta. Now, notice that before we're going to multiply, because that is the product of two binomial, now we have to add the term, the expression inside the enclosure symbol or the parenthesis, so that when we are going to add this first binomial, we have to get the the LCD. And so what is the LCD of cosine theta over sine theta plus 1 over sine theta? That is the same as sine. Okay, sine theta, that is the LCD. So now let's try to add sine theta divided by sine theta, 1 multiplied by cosine theta, it will give you cosine theta. Okay, it will give you cosine theta. Now what about this one? Sine theta divided by sine theta, that is of course 1 multiplied by 1, and so we have plus 1. So that is the result. Now another one is we have in here, what is the LCD? Our LCD is the same, sine. Okay, sine theta. Now sine theta divided by sine theta, that is 1 multiplied by cosine theta, that is the same as cosine. That is the same as cosine theta. Okay, cosine theta. Notice that when we continue, sine theta divided by sine theta, that is the same as 1 multiplied by 1, so that is the same as 1. Okay, yan. That is the resulting sum and product of the trigonometric expression inside the parenthesis. Now, what is the next thing that we are going to do? Notice that this is already multiplication. Multiplication of fractions. So how do we multiply? We have to multiply numerator to numerator, denominator to denominator. And so when we are going to multiply, our result, we will multiply the denominator first. Sine theta multiplied by sine theta, it will give you sine squared theta. Now, what about the numerator? Notice that this is actually the product of two different binomial. Okay, so if we are going to have the long method, we say long method, we multiply this one, cosine multiplied by cosine, then cosine multiplied by negative 1. So the result is cosine squared theta, ayan, cosine squared theta minus negative cosine theta, ayan. Now, what about the next? This will be the next. We distribute this one, we multiply it here, and then we multiply it there. So, ayan, multiplied it here, and then we multiplied it again in here. So, it will give you now 1 multiplied by cosine theta, positive cosine theta. Okay? 1 multiplied by negative 1, it will give you negative 1. Notice that after having the multiplication, we are going to combine similar terms. Okay, so let's try to put it here, continue on top. Okay, so combine similar terms. Yan. Cosine squared theta is alone, so we copy. Cosine squared theta is alone. Now, but you notice this one is similar. So this is 0. Positive, negative, so it will give you 0. What is left now is minus 1. Okay? What about the denominator? Our denominator is sine squared theta. Okay? Sine squared theta. Notice that when we are going to look into this one, analyze, this is actually under the Pythagorean identities. This one, okay? Pythagorean identities. How about this one? Is still the same, Pythagorean identities. And so let's try to change this one, okay? In terms of cosine, okay? Change the denominator in terms of cosine. So remember that when we have the sine squared theta plus cosine squared theta, that is the same as 1. Okay, so if we are going to change this one to get the value of sine squared theta, we have to derive it from our Pythagorean identities. So our sine squared theta in here is actually what? 1. You transpose that one, so negative cosine negative cosine squared theta. Okay? So by substitution, we can change now our denominator. So we will be having now an expression that state that cosine squared theta over 1 is with a denominator of the same 1 minus cosine squared theta. Now notice that our 1 in here is negative, our 1 in here is positive. Same true that our cosine squared theta in here is positive. This one is negative. And so how are we going to do to simplify this one? Now, what you will be doing is you think of a factor that when you multiply it back, it will give you the same result. Okay, it will not change the result. Okay, now, so if that is the case, we can put this one to be negative and we can convert this one to be positive. And so I will factor out negative 1 in here in the numerator. So if I will factor out negative 1, what would be the factor of cosine squared theta in order for that when I will multiply that factor and this negative 1, it will give you the same result, positive cosine squared theta. The factor is negative cosine squared theta. Okay? Now, what about this one? What about if I factor out negative, what is left? It must be positive 1. Okay? Now, our denominator is the same as 1, okay, minus cosine squared theta. Notice that in here, we have the same now, positive 1, negative cosine squared theta, negative cosine squared theta. So that, if they are already the same, now, what are we going to do? We can cancel out now this numerator and denominator. Okay? And so, after canceling out, what is left now is 1. So, the result is actually 1. Negative 1. Okay? So, negative 1. So, that is the result. So, the result of our problem in here, or the simplified form of this cotangent squared theta minus cosecant squared theta is actually negative 1. And so that is the result of the expression. Okay, I hope you understand this one. So you try to go over with it. Okay, you try to go over with it, and you try to analyze how we try to answer the problem. Okay. Another expression that we are going to simplify, put it into its simplest form, is the quotient of cotangent theta plus tangent theta over the product, which is secant theta multiplied by cosecant theta. Now, how are we going to put this one into its simplified form? Now, again, the technique is memorize the basic trigonometric identities, the reciprocal identities, the quotient identities, and the Pythagorean theorem identities, because these are all very important thing to use to simplify trigonometric expression. Okay? Now, how are we going to simplify this one? Okay? Number one, you see to it, if you notice that you cannot see any cosine or sine expression. So immediately what we will be doing is we are going to substitute the expression using its definition in terms of cosine and sine. So let's try to have. Okay. What is the definition of cotangent in terms of cosine sine? So the result of this one is cosine theta over sine theta. Yan. What about this one? that is the same as tangent theta is the same as sine theta divided by cotangent cosine, I should say cosine theta. Okay, now what about our denominator? Our denominator is the secant theta is the same as 1 over cosine theta. So our denominator is actually a product, and so we enclose with an enclosure symbol. How about this one? Cosecant theta. Cosecant theta is actually 1 over sine theta. Okay? So notice we have a complicated fraction or rational number in here, or rational expression. Now, what is the next thing that you're going to do? Okay? What is the next thing that we're going to do? Of course, we add first this one and then we multiply before we are going to do this operation. Okay? Before we're going to divide. And we will add first that one, the numerator, we will multiply, get the product of the denominator. So let's try to have the sum of the numerator. The sum of the numerator, get the LCD. What is the LCD? Our LCD is sine theta cosine theta. Okay? So, if you try to notice, sine theta, cosine theta divided by sine theta, the result is cosine theta. Cosine theta multiplied by cosine theta, it will give you cosine squared theta. Okay? Now, what about this one? Sine theta, cosine theta divided by cosine theta. The result is sine theta. Sine theta multiplied by this one is the same as plus sine squared theta. Actually, if you notice, we just cross multiply. Okay, we just cross multiply. Sine theta multiplied by sine theta, it will give you sine squared theta. Cosine theta multiplied by cosine theta, it will give you cosine squared theta. Of course, the denominator must be the LCD, or the product of the two fractions. Okay. Now, what about the denominator? 1 multiplied by 1, it will give you 1. Okay. It will give you 1. Cosine theta multiplied by sine theta, it will give you just the same. Sine theta cosine theta. Okay. So, notice that we have a rational number. And so, what are we going to do if that is a rational number? Now, we get the reciprocal of the denominator and then proceed to multiplication. Okay? So, our denominator is in here. So, what is numerator? Let's try to copy the numerator. Cosine. The numerator is cosine squared theta plus sine squared theta over this one, sine theta cosine theta. Okay? So, ayan. Now, what is the reciprocal of this one? The reciprocal is sine theta cosine theta, the reciprocal of this one, over 1. Now, notice that we have now in here the product of the resulting product. So, notice that our numerator in here can be cancelled out with this denominator. Okay, sine theta, cosine theta is the same as sine theta, cosine theta. Now, what is left now? Let's try to continue it in here on top. Okay, what is left now is, yan, I think this is already the final. Cosine cosine squared theta plus sine squared theta over 1. That is what remains. But you will notice this sine squared theta plus cosine squared theta, or cosine squared theta plus sine squared theta, is the same as the Pythagorean identities. Now, what is our Pythagorean identities? That is, you have to recall that one. Pythagorean identities, sine squared theta plus cosine squared theta is equated to 1. Okay? So, meaning to say, by substitution, we can substitute our numerator, and so that our numerator is the same as 1. So, what is left now? What is left now as final result is 1 over 1, which is the same as 1. So, the result, or the simplified form of this cotangent theta plus tangent theta over the product of secant theta and then cosecant theta is actually 1. Okay? So that is the result. Okay? I hope you understand. What we did with our problem. And now another one is the product of tangent squared theta and cotangent squared theta. Okay? So what is our purpose in here? We are going to simplify. Okay? Simplify again, put this one into its its lowest term. And so how are we going to put this one into its lowest term? Again, consider again the idea that when we are going to simplify, we always define them in terms of cosine and sine. So what is the definition? Okay, step number 1. What is the definition of tangent? Okay, tangent is the same as sine. Okay, tangent is the same as sine theta. Okay, over cosine theta. Of course, that is raised to the second power, and so we raise it to the second power. Okay? Now, what about the cotangent? Cotangent, that is the same as cosine theta over sine theta. Okay? Of course, that is raised to the second power. You might be saying, can we not just cancel out this one? No, why? Because they have their exponent. Okay, so the next thing that we are going to have is after defining them, you notice that okay, we distribute, so that is the same as sine squared theta over cosine squared theta. Okay, multiplied by, that is the same as cosine squared theta over sine squared theta. So we can now, it's very obvious now that we can cancel it out. So this must be sine squared theta divided by sine squared theta. That is 1. Okay, that is 1. Another one is cosine squared theta divided by cosine squared theta. That is still 1. So the result of this expression is actually 1 multiplied by 1, it will give you 1. Okay? It will give you 1. So the result of the product of tangent squared theta and cotangent squared theta is 1. Yan. I hope you got the technique. Okay? So that is the first part of our verification of trigonometry, or simplification or verification of trigonometric expression, or again, simplification of trigonometric expressions. Okay, thank you. So before we end, now we just try to look into, okay, let's try this one.